Good afternoon everyone. I am Muthu, Associate Professor, Department of PCE. Now I will be handling electromagnetic field, part 1 of electromagnetic field theory. So this is the syllabus concerning the electromagnetic field. Unit 1 deals with introduction, coordinate systems, vector algebra, review of vector algebra concepts, divergence and curl of vector field. The second unit deals with electrostatics, electric field due to different devices, and Gauss law, electric field due to a dipole. And another new topic is introduced, electric field plotting using MATLAB. Then the visualization of capacitance comes into this unit of electrostatics. Then end of this unit deals with electric boundary condition. Third unit deals with magnetostatics. This is movement of charges with constant current. So this is the unit we are taking. So this unit deals with different laws as Ampere's law, Weierstrass's law, and magnetic potential, magnetic current. This is the introduction to this magnetostatics. And device used for this unit 3 is inductance, magnetic materials, magnetic forces. So that we will try in unit 2. Unit 4 deals with Maxwell's equation, which is the base of electromagnetic field theory. So from Faraday's law and the other laws which are written in unit 2 and 3, we will bring into Maxwell's equation. Unit 5 deals with electromagnetic wave propagation, like reflection and diffraction and diffraction. So these are the course outcomes designed for this subject. We have got 6 course outcomes. First, CO1 deals with different coordinate systems in spatial and time domain, and you have to apply different techniques to understand the concepts of electromagnetic field. And unit 2 deals with laws pertaining to voltage and current. So that is charges and current in electric field and magnetic field. Unit 3 deals with electromagnetic devices such as inductors and capacitors. And 4 also deals with inductors and capacitors. 5 deals with the Maxwell's equation. 6 deals with the electromagnetic wave propagation. And we have got the levels as applied level, and the last one deals with the analyzed level. So now the next one will be the introduction of electromagnetic field. So why we need to know electromagnetic field? What is electromagnetic field? It is the interaction of electric and magnetic, the charge and the magnetic current distribution. So that is combined as electromagnetic field. So we have to learn these 3 questions before going into this introduction. What is field? How are these fields generated? How do these fields interact? So this session will be warming up to electromagnetic theory. So the goal of the next few minutes is to see why electromagnetic theory is necessary and why circuit theory has failed in different situations. So now we have a circuit like this. So a circuit, 2 long pair of wires connected to a signal source. We have got a switch over here. So this is the question given. So what will happen? The answer, the multiple choice question answer is also given. The first answer is nothing. Current will flow for a short time. Outcome depends upon the length of the wire, and outcome will depend on the length of the source. So as far as a circuit person is concerned, what will the circuit person say? Since it is not connected at the output end, it is free, it is an open circuit, the output will be nothing. That is as far as the circuit theory is concerned. Circuit paradigm cannot answer this question. So the output will be nothing. So as far as electromagnetic theory is concerned, we have got answers for all from B to D. Current will flow for a short time. It will also depend upon the length and shape of the wire, and the outcome will depend on the frequency of the source also. We will see in the next coming slides what is the nature of the length of the wire, what is the frequency of the source, and what is the flow of the current. So this is how the circuit person sees. He sees the circuit as an open circuit. So no current flows. So it is nothing. So now consider this. Now consider the circuit. The wire is bent. This bent wire is connected to a signal source, and it is connected to a pair of resistor, and you have got an oscilloscope. Now, this wire bent will mean nothing in circuit theory. Whereas in electromagnetic field theory, this bent wire will be as a transmission line at high frequency and as an inductor at low frequency. So this circuit is like this, and as far as this circuit is concerned, circuit theory, whatever input is at the voltage source, that will occur at this output oscillator. So if it is 5 volts, that will be the output 5 volts at the oscillator. But electromagnetic field theory will not give the answer like this. The bent wire, it will mean as an inductance. So current will flow for a short time. From the basics of physics, the current will flow for a short time, and the frequency of the source also matters. There will be some frequency of the applied source. So the frequency will get changed at the output. That is from the electromagnetic field paradigm. So frequency also changes. So current flows through the wire even when it is bent, but there is a delay. So the voltage and current V by I is described as a wave in electromagnetic field theory. So this is how the EM person sees. So this is a EM guy. When he is looking into this bent wire will behave as inductance at low frequencies and that transmission line at high frequencies. So from this we learn to calculate what is inductance and what are the value of inductors in different fields. So next, coming back to the circuit. Now we see how the shape of the circuit matters in electromagnetic field theory. Now we have got a circuit like this. So circuit is connected to the two long pair of wires connected to a signal source. So this signal source is connected to oscilloscope. At the load end we have got a resistor. So these are two metal plates. So metal plates, in between the metal plates there is a gap. It is not joined together. So from circuit theory, the output will be 0 because wire is cut, no current flows to the wire, output is 0. So when coming to electromagnetic field theory, we consider this as a capacitance. Two plates separated by a dielectric medium. So we have got two plates like this, separated by a dielectric medium. This will be regarded as a capacitance. So here we understand what is capacitance. There now we need to know why electromagnetic theory is necessary in free space, whereas these questions are not answered by circuit theory. So now the length of the wire is not taken into account in circuit theory. Now these two wires are connected to a signal source. There we have got the oscillator. So as a circuit person, what they will say, whatever voltage 5 volts is there at the input, that will be at the output source. So when coming as an EM type, it is a little bit confusing. See the voltage, this is the input voltage, and there will be a phase shift at the output. That phase shift is nothing but a delay. Phase shift is nothing but a delay in electromagnetic field theory. So that is the voltage by current. The wave will take a short delay to reach the other end of the wire. It does not reach immediately. It is called as retardation. So that is delay. The delay is called as a wave. That is nothing but L by D in electromagnetic field theory. So now all these parameters are summed up. So we are taking into account of time delay. Then we are taking also the phase. Phase also changes at the input and phase also changes in the output. And at low frequencies it behaves as inductor. At high frequencies it behaves as transmission line. So all these questions were answered by electromagnetic field theory and circuit field theory failed to answer these questions. So this is how voltage is calculated in terms of electric field and current is calculated in terms of magnetic field. So simple circuit gives answers to the questions in terms of electromagnetic field theory. And now we are finished. The electromagnetic field theory is necessary So when this was necessary, what was the first question we need to know? Field. We need to know what is field. From field, we need to classify what is vector field and what is scalar field. Field is a point which describes a quantity in free space. A physical quantity in free space is called as field. So it is describing some source or some charge in free space which is called as field. So this is a diagram which is called as the source. Source is nothing but charges. So when you exert the source, you have got lines spread apart. These lines are called as field lines of resistance. So force exerted on a charge will give you field. So force exerted on a charge is called as field. So this is one charge which excites these lines. We have got another test charge placed in a satellite. So this is a charge placed in a earth. So what is happening due to the test charge on this charge? Field lines are generated. So field lines are generated at A at one point, and at about 9:30 AM field lines are generated at B. So this is how field is generated in different situations. So this will explain what is field. So this will give the answer. The force acting on a discharge is called as electric field intensity. So we come to know what is electric field intensity. The next one is called, these are the basic review concepts, scalars and vectors. As we have already gone through what is scalar and what is vector, we can now clearly correlate what is scalar field and what is vector field. Scalar is already correlated. Scalar we already know it is characterized by its magnitude. Vector we already know it is characterized by its magnitude and direction. Now this field which describes a physical quantity is describing only magnitude is called as scalar field, and the quantity which describes both magnitude and direction is called as vector field. So this is a representation of vector. So representation of vector, we have got 2 points. This is a head, this is a tail. That arrow, that is a terminating point. So this is the distance vector r. So distance vector r is OA vector, which is the magnitude of this line, which is r. The next is the unit vector. The unit vector, what we consider the magnitude of the vector to be unity. And as a mathematical concept, it is OA vector divided by magnitude of OA vector. So this is going to be unit vector. The next one, we have got different concepts of vector algebra, like scaling, addition and subtraction. We don't subtract, we only add, and scaling is the property where we multiply a scalar with a vector product. So this is a vector as we already seen, this is the distance vector, this is the tail and this is a head point arrow, and this is going to be a vector with radius with the distance r. And if it is multiplied with some scalar product alpha, this is called scaling of vector. It is multiplying by a scalar product. It's called scaling of vector. So you can multiply by any value. So that is called as scalar. It can be 1 greater than 1, less than 1, and so on. Next is the addition of it. It's a very important concept, beautiful concept when we want to add 2 vectors. So this becomes easy. Like we are having A, we are drawing a vector like this OA, that distance is A, and this is from A to B, this vector is B. So this is OA is equal to A vector, this 4B is equal to B vector. So we are adding this, how to add these vectors. So we can have, see this diagram which visualizes this is B vector and this is going to be A vector. Now we want to find the answer to C. So this was the original diagram. This was the original diagram. So we are moving a parallel line to this. So this becomes A vector. So this becomes B vector. So we can have these two are mathematically equivalent. These two are mathematically equivalent, but physically they are not equivalent. So this point is a parallel representation of this. So this is B vector, this is A vector. So C vector will be the addition of these two vectors, which is A vector plus B vector. So this satisfies also commutative now. So we have A vector plus B vector is equal to B vector plus A vector. So this is not only C vector, we can have addition of multiple vectors. So that is B vector also. So we are adding A plus B same method, same recipe is followed for the addition of factors. So these satisfies all commutative laws. We know commutative as a mathematical concept. A plus B is equal to plus A, associative and distributive. So this vector addition satisfies all these laws. Next, subtraction of vector. So subtraction, we usually don't subtract vectors. So as we have already seen, this is A vector, this is B vector. So subtraction means this we have to have minus 1. So we take a opposite direction, so that will become minus B. Now then add these vectors, C is equal to A vector minus B. So it should be in the line must be drawn in the opposite direction, so we have a minus sign. Then we are going to add these two vectors, that is called as vector subtraction. C is equal to A vector plus the operation is plus of minus B. Then this will be the introduction to coordinate systems, Cartesian system, cylindrical system.